Hello everyone, in today's video, we discuss how many pods can be placed on a single EC2 node in AWS EKS. The Kubernetes reserved resources, system reserved resources, IP addresses, and pod requests and limited resources affect the number of pods on AWS EKS EC2 node. To put it simple, the available CPU, memory, and IP addresses on the EC2 node are key things influencing the total number of pods that can be hosted. There is an example. We can deploy 11 Nginx pods to one T3 middle EC2 worker node. If you're interested in how do we get the CPU, memory, and IP address usage, let's dive into it together. Hello everyone, welcome back to my channel. My name is Lian Duan, and I have developed for over 20 years, specialized in DevOps and cloud security. All the video read to Markdown file and the source code are in my GitLab repository. The links are below. Today we'll cover below topics where we can find the EC2 instance hardware size, how to calculate CPU, memory, and IP addresses usage, and 3 hands-on demos. Find the EC2 instance available IP address in 2 ways. Figure out Daemonsets of CPU and memory in EKS. Test the EC2 node capacity. EC2 T3 middle instance will be used in my demo. Let's move to first topic, how to find EC2 instance hardware size. We kick things off by understanding the various EC2 instance types. There are linked different models of computers you can choose from. My demo box under the T3 types. The instance type is T3 middle. It has 2 vCPUs and 4 GB memory. Back to my Markdown file. Next, we explore the number of IP addresses available for each work interface and different interface types. Each pod requires its IP address. This is why we need to know how many IP addresses are for each type of EC2 instance. Open the document, move a little bit down to find T3 instances. You can see T3 middle has 17 available IP addresses. Back to Markdown file again. Now let's break down the process of CPU calculation for Nginx pod. CPU usage has 3 parts. One pod uses 12.5% CPU time. So total is 12.5% multiplication 1000 millicore CPU time and multiplication 11 pods. The total is 1375 millicore CPU time. The 12.5% CPU time is from nginx-deployment.yaml file under the limits CPU session. Kubernetes and operating system reserved resources is 140 millicore CPU time. It from the AWS source code. There is no official document to refer it. If you find it, please let me know. There is a source code. There is my formula is coming from. We have 2 cores, so the CPU usage is 7%. Back to the Markdown file. The daemon size use 450 millicore CPU time. I'll demo how to use kubectl describe node plus node name command to find it in later hands-on demo. The total CPU usage is 1965 millicore CPU time, which is less than 2 vCPU time. So we are good to deploy 11 Nginx demo pods into our target EC2 node. Let's process step by step and calculate the total memory usage. Each pod uses 256 megabytes memory. So 11 pods needs 2.8 gigabytes memory. We use the limits of memory to assimilate the memory usage. The Kubernetes uses 431 megabytes for 16 pods. The formula from the AWS source code. Let me open it. There is a highlighted formula. Back to the Markdown file. Daemonsets need 340 megabytes memory. I'll demo how to use the kubectl describe node command to find the Daemonset memory in my hands-on demo. The total memory usage is 3.5 gigabytes memory, less than the 4 gigabytes. So the 11 port is good for the hardware size. Hold on, one important thing are missing in the slides. What is? EC2 Instance Operation System use memory. How do we get its memory usage? I just launched T3 middle EC2 instance with the latest Linux operation system and run free command to get memory usage. You see, the system uses 154 megabytes memory. We put some buffer in here, so operation system allocated 200 megabytes memory. The total memory usage increased to 3,787 megabytes memory, still lower than 4 gigabytes memory. IP addresses usage calculation is simple. Nginx ports need 11 IP addresses. Daemonsets need 5 IP addresses. Total IP addresses is 16, less than the 17, so we're good. After we understand all concepts, we move to the hands-on demos. First things first, we need to make sure our EKS cluster is up and running. If you do not have set up it yet, do not worry. Check out my videos for step-by-step guideline. Create AWS EKS using Terraform, and create EKS cluster using AWS console. Choose which one you like. If you have any questions, drop them below, and I will help you out. Open the nginx-deployment.yaml file. The file is under the code folder. You can find it in my GitLab repository. This file helps us deploy a simple Nginx web server, which has my customer index homepage. In the spec session, we try to deploy 12 Nginx ports. Based on our calculation, 11 of 12 ports should be successfully deployment. One port cannot be successfully deployment. We use the limited part to assimilate CPU and memory usage. If you're interested in the resources part, there is my video, how to configure Kubernetes resources quotas in namespace level and individual pod. With the prerequisites in check, let's move forward to the hands-on demos. Open the terminal. First demo, how to find EC2 instance available IP addresses. First, get the available node in cluster. There is only one node in the cluster. Run kubectl describe node plus node name to get the worker node detail. Go to the capacity part. There is a pod value is 17, which means available IP addresses is 17. Also, we can find the same information in the EKS console. Open the EKS demo cluster 01 and move to the computer part. Under the nodes section, open the node. Under the capacity allocation, there shows us we are able to deploy 17 pods in this cluster. 5 pods are deployed, 4 is add-on, 1 is a matrix server. Back to the terminal. Next demo, I'll show how to find the Daemonsets of CPU and memory usage in the same result. We move a little bit down. I highlighted CPU and memory usage, which one requested by the Daemonset. Clean up the screen. Latest hands-on demo. Let's try deploy 12 pods into the EKS node. Run command kubectl apply plus YAML file. Deployment successfully. Use kubectl get pod command to retrieve the pod started. You see there 11 pods are running, 1 pod in the pending status. Run kubectl describe pod plus pod name to get the reason why the pod status is pending. There is a reason: insufficient CPU, insufficient memory. All topics and hands-on demos are completed. That's all for today's video. We learned how to calculate and check capacity EKS EC2 node. Thank you for watching and see you in the next time.